Hello students, today we are going to see a category of problems that comes under motion in a plane. So here we will make use of relative motion concept here. Okay, we have already studied a relative motion concept in one-dimensional motion. Here we will be using relative motion with the background of 2D, two-dimensional, that is two-dimensional relative motion we will use in order to solve this kind of problems. So here you can see in the heading swimmer river problems. Okay, so the context is like a flowing river will be there and a swimmer will be jumping into the river. So based on the direction in which he jumps, either he will be reaching exactly opposite or otherwise there is going to be a drift. Okay, so I will explain the context, okay, how each value should be taken. Okay, we will understand that first, then we will start problem so that things will be easy for us. Suppose if this is a river, okay, so this river will have a velocity, we can say VR, okay, velocity of the river, and this river will have a width also, river will have a width. Now suppose if a person tries to move in this direction, suppose if the swimmer is moving in this direction, his intention is to move in this direction and actually he jumps in this direction, then because of the effect of this reverse velocity, where he is going to join, definitely he is going to join somewhere like this. So if this is point A and opposite point if this is B and if this is C, this distance we call as drift. This is called as drift. Okay, so from the opposite point, how much horizontal? So here we will be making use of vectors so that things will become very easy. Okay, so just understand this direction, we will consider this as, suppose if we consider this as horizontal, then this one we will be considering as vertical. Obviously it is not like this and this, okay, not this vertical motion, but for our solving, for doing the solution, we will be considering this as J and we will be considering this as I, or simply I can say this is X and this is Y. Okay, so not conceptually exactly this is not vertical, the motion is not like that. Okay, we will be just taking this as J. Okay, that's it. More precisely, if I need to precisely say, I can remove this horizontal and vertical. Okay, I can remove, instead I can say that precisely this is Y axis, that is X axis, that is going to be I, this is going to be J. So okay, that is conceptually correct. Okay, so we will be taking like that, right? Suppose if the person is, okay, do you understood this scenario? Okay, each point is important. So okay, each point is important. If we understand and do, then things will be easy. Suppose if this is the river, if this is width, if the person wants to reach exactly B, suppose if this is A and if this is B, if he really wants to reach in this direction, then definitely he must be swimming in this direction. This must be the velocity of the swimmer, then only he will be reaching in exactly opposite this angle is also important. Okay, if the angle is more, if this angle is more, he will be reaching here. If this angle is less, he may reach here. If he exactly using this, if he uses this angle in the proper manner, then only he will be reaching the opposite direction. Okay, so all these things understood, right? Right, fine. Now I want to tell certain more points. Shall I erase this? Okay, now suppose this is river. Okay, if a person wants to swim, if a person wants to move to opposite direction, but he jumped and he started swimming in this direction. So this is velocity of this swimmer. Okay, velocity of the swimmer with respect to river, we can say. Okay, or otherwise we can say, or I'll write here, or velocity of swimmer in still water. Why I am saying this? Velocity of a river with respect to velocity of swimmer with respect to river. Why I am saying, suppose if this person's name is Manoj, another person is also jumping, his name is Babu. If he is also jumping in this direction, okay, then because of the reverse velocity, actually based on the reverse velocity, if this reverse velocity is too much, if the reverse velocity is too much, then these two guys may actually go in this direction. Reality, in real, okay, for a person looking from ground, this is ground, okay, this is ground, this is river. So for a person looking from outside, we could see that Manoj and Babu, they are drifting into that direction just because velocity of the river is too much. But if Manoj looks at Babu, he will feel that he is also swimming straight. When Babu looks at Manoj, he feels that we both are swimming in the straight direction, in the straight line. Okay, so that is the reason we are saying that this is like a velocity of the swimmer with respect to river. A velocity of the swimmer in still water is what? They are trying to jump. Actually, in which direction they are moving, that is velocity of the swimmer with respect to ground. Okay, note down those points also. Okay, now the meaning of this velocity of swimmer in still water. Suppose if the water is still, if he jumps in this direction, definitely he will be moving in this direction. Correct. So in whatever using whatever velocity the swimmer is jumping and he is trying to swim, that is his original capacity and that is its velocity in still water. Okay, we should take like that. Now because of reverse velocity, definitely his direction will change, the resultant velocity will change. All those velocities are the real, that is nothing but the velocity of the swimmer with respect to ground. Okay, now with one more point I am saying, with that we will get into the questions. You doing problems, we will understand the concept easily. One thing, suppose in the question if they say that the velocity of the swimmer in still water is so and so, we should understand that that is the velocity with which the swimmer will be trying to swim. Okay, so if they are jumping with in this angle with this so and so velocity, we can take that velocity as the velocity of the swimmer. Okay, like that. Then after that we will be able to find the velocity of the swimmer with respect to ground and all based on the question. Okay, right. So velocity of the swimmer in still water is the velocity with which he is trying to swim. Okay, velocity of the swimmer with respect to ground is the real situation which is going to happen when we look from outside. Okay, right. So with this introduction, slowly we will do problems. So our first problem is okay, so this is the river, its width is 16 kilometers. Okay, the velocity of the river is 3 kilometers per hour. Okay, velocity of the river is 3 kilometers per hour, and velocity of the swimmer with respect to river is 4 kilometer per hour. Okay, or velocity of the swimmer in still water is 4 kilometer per hour, and he is jumping straight. Okay, so suppose if this point is A and if this point is B, the direction of swimmer is directly pointing B. Okay, from A. Understood? The width of the river is 16 kilometer. The velocity of the swimmer, if he is trying to swim, is 4 kilometer per hour, and he is trying in which direction? From A to B. This is the direction in which the swimmer tries to swim. Okay, sorry, statement. Okay, clear? These are the datas. Now first question, I will give one by one. First question is time taken to reach the opposite side. Time taken to reach the opposite side. This is the question. Okay, now pause the screen, try with your understanding and approach, then verify the answer. Okay, pause the screen and try. Okay students, so here we need to find the time taken to reach the opposite side. Now see, I am going to do in this way, that is, this width of the river is 16 kilometer. Width of the river is 16 kilometer. The only velocity which is available, so this I am considering as J direction. So the only velocity which is available in J direction is 4 kilometer per hour. So I could say that velocity of the swimmer with respect to river is given. So 4 kilometer per hour. I am going to put this as 4J, and the width of the river I am going to put as 16J. Now if I need to find the time taken to reach the opposite side, what can I do? V is equal to S by T, and V is equal to S by T, and T is equal to what? S by V. So S is nothing but here 16 kilometer. This is also J, that is also J. Divide by V is equal to what? 4 kilometer per hour. So if we cancel them, kilometer, everything will be cancelled off. This is going to be 4 hours over. Okay. So what we are going to do here, in order to find time, either we can take horizontal velocity and horizontal displacement, or we can take vertical velocity and vertical displacement. Bas over. Right. So where we are using here relative velocity, relative motion, we are using here, but without much trouble, so we may not notice. See, velocity of the swimmer with respect to river is nothing but velocity of the swimmer with respect to ground minus velocity of river with respect to ground. So here velocity of river with respect to ground we know, velocity of the swimmer with respect to ground we do not know, velocity of swimmer with respect to river we know. Okay, so certain questions we will use this equation, okay, without much difficulty. Okay, did you understand this question and that answer? Now we can have another question. What is the drift? Or suppose in which point, okay, from B, okay, how far the point of touching from B on the opposite side, that is what is drift. Or suppose if this point is C, how much is this distance? Okay, that question also can be asked. Okay, so if that is asked, how we will solve? See, drift is nothing but what? Drift is nothing but horizontal displacement. So horizontal displacement, S is equal to V into T, S is equal to V into T. So this is the, see, this velocity of this swimmer is the original velocity, that is the velocity with which he is trying. This is actually velocity of the river, original velocity of the river. The effect of these two will be different. The resultant velocity of the swimmer can change, but this is y vector, that is x vector. Okay, now see, x is equal to what? Vx into t. T already we have found. For t we can use anywhere. So what is Vx actually? Vx is the only Vx which is available is this reverse velocity. Okay, this is a system, right? The swimmer, river, everyone is a system. So what we can do here, 3 kilometer per hour into 4, we are getting 12 kilometer. So this drift is nothing but, this distance is nothing but 12 kilometer. Okay, so he is going to reach this place. Clear? Note down. Okay, now shall I erase this? Now see students, suppose if this is river, okay, this is velocity of the swimmer 4 kilometer per hour, and this is the velocity of the river, which is nothing but 3 kilometer per hour. Now with respect to ground, we will understand the real scenario. Okay, this swimmer may not understand properly in which direction he is going. Okay, he should go, when he goes in this direction, actually he is moving in this direction. So the real direction, the real velocity, all these things will be understood from a person standing on the ground. So based on this, First question, time taken to reach the opposite side. This is nothing but drift, actually where he is going to stuck. So this distance is fine, 16 kilometer, but this is the actual distance. This is the actual distance. So when he touches this place, this distance, this is how much? 16 kilometer, and from here to this is actually 12 kilometer. So if this is A and this is B and this is C, this AC is the actual distance covered. Actual distance covered. So after these two questions, another possible question is what? Actual distance. Actual distance. This is what? The real distance. So how to find the actual distance? Actual distance we can find, suppose AC. See, this is a vector, this is a vector. So root of x square plus y square bus over x square plus y square. So this is equal to root of 16 square plus 12 square. So 256, 144, 400, we will be getting 20 kilometers. So he will be swimming actually 20 kilometers. This is the actual distance. Or we can write in this way, 12 kilometer I plus 16 kilometer J. I have put just the unit here simply. We can write based on the ratio. If you want, we can write 12I plus 16J in the form of vector. Clear? Okay. So 12I plus 16J kilometers. Okay. Actual distance vector. Clear? Now suppose for a person standing on the ground, how much velocity he will feel? He will feel that the velocity with which shall I raise this? Okay, so the velocity of the swimmer with respect to ground, okay, from a person observing from here, what he will feel. So for that, what we can say, velocity of the swimmer with respect to river is what? Velocity of the swimmer with respect to river is what? Straight. So this is equal to velocity of the swimmer with respect to ground minus velocity of river with respect to ground. So velocity of swimmer with respect to ground is what? Velocity of swimmer with respect to river plus velocity of river with respect to ground. So this is going to what? 4J plus what? 3I. This is the velocity of the swimmer with respect to ground. He will, for a person looking from outside, he will understand that he is swimming in this direction. So actually we are using relative velocity, relative motion concept, but without doing much strain, without worrying much about that. Just by taking x component, y component, we can find time, drift, everything. Okay, please note it down. Okay, we will do another problem. Take down next problem. So this is a river. Okay, so here the width is 30 kilometers. So a man is jumped into water and he is swimming at a 10 kilometer per hour at an angle 37 degree with the horizontal this direction. Velocity of the river is 8 kilometer per hour. Okay, so this is the velocity of the swimmer in still water. This is the velocity of the river. His actual if he is swimming in still water, this will be the velocity. Since because of this river's velocity, changes will happen. Okay, that is what the situation is. So he is moving at a 37 degree. This is the velocity of the swimmer. So one by one we will do all the possible questions. So first question is time to reach the opposite side. Time to reach the opposite side. Pause the screen. Okay, you think and try to solve this problem. Okay, all right, done. Okay, now we will do. Right, so here he is trying to swim in this direction. Okay, he is trying to swim in this direction. So his this swimmer's, what we need his horizontal component and vertical component. In the previous question, he was actually swimming in the opposite direction. Okay, because of river he drifted. So here in this case, in this direction he is moving. So what I am going to do is I will resolve this vector into x and y. Okay, so this one and this one. So his velocity we are resolving into 10 sine 37 and this is 10 cos 37. So we know this triangle, right? So if this is 37, this is going to be 3, 4, 5. So 10 cos 37 means 10 into 4 by 5. 4 by 5. So this will be cancelled off. This is going to be 8 kilometer per hour. So that is one thing. Here this is going to be 10 into 3 by 5. So we will be getting what? 6 kilometer per hour. 6 kilometer per hour. So we got the vertical component of velocity. So in order to find time, what can we do? So t is equal to what we will take? We will take Vy divided by y divided by Vy. Okay, we will take y divided by what? Vy. So y is how much? 30 kilometer and Vy is how much? Vy is this one. So 6 kilometer per hour. So it's this 6 and 30 if we cancel, we will be getting 5 hours. 5 hours. So this is the time taken to cross the river. Okay, clear? Okay, so simply if a swimmer is exactly moving in the opposite direction, so that is its his y component, time that can be found directly. Otherwise resolve it, find the x component and y component, time can be found from the y component. Now next possible question is what? Drift. Next possible question is drift. Okay, so will there be any drift here? What is the overall x component of velocity? Reverse, it is nothing but 8I and the swimmer is minus 8I. So this is actually 0. The overall velocity in x direction is 0. Okay, so we can understand that he is going to move. Okay, so since there is no drift, he will be swimming in the opposite direction itself. Then velocity of the swimmer with respect to ground will be what? Velocity of swimmer with respect to ground is nothing but velocity of the swimmer with respect to river plus velocity of the river with respect to ground. Previously we have seen this formula. Just applying this, velocity of the swimmer with respect to river is equal to velocity of swimmer with respect to ground minus velocity of river with respect to ground. So from that, velocity of the swimmer with respect to ground is nothing but velocity of swimmer with respect to river plus velocity of the river with respect to ground. That is what we are going to write. Now velocity of the swimmer with respect to ground is what? Velocity of the swimmer with respect to river is this one. So that is nothing but 6j and minus 8i. So minus 8i plus 6j and this one plus 8i. So this and this will be cancelled, right? So velocity of the swimmer with respect to ground is going to be only 6j. Some of you might have confused like how can I cancel this one and that one? This is the whole system. Well, if we want, we can put this step and all. Velocity of the swimmer with respect to ground, we can write all these things, formula we can write. Need not waste time on that. Simply what we can do, just given velocity of the swimmer, just mark it. If necessary, if it is not exactly in the x direction or y direction, resolve them, cancel with the river, then find time. With the component in the x direction, we can find drift, we can find actual distance. All these things can be done. Okay, note it down. Okay students, so we will do another question. A man can swim in still water at a speed of 3 km per hour. Okay, so a man can swim in still water. So velocity of swimmer is 3 kilometers per hour. Okay, he wants to cross a river that flows at 2 km per hour. So velocity of the river is 2 km per hour and reach the point directly opposite to the starting point. Okay, so this is the situation. Okay, so if we start from here, he wants to reach exactly the opposite point. Velocity of the river is 2 km per hour. So the question is, in which direction he should swim, okay, in order to reach directly opposite to the starting point. In which direction he should swim. So find the angle his body makes with the river flow. Okay, find the angle. Suppose if this is the river flow, this is the river flow direction. So if he is moving in this direction or this direction or this direction, whatever it may be, what is the angle? Theta with respect to the river flow. That is one question. Another question is to find the time to cross the river. They have given like this river is 500 meter wide. Okay, so now so just pause the screen and try to solve this question. Okay, and then verify the answer. Okay, so okay, done. Shall I do now? For the swimmer to cross exactly the opposite point, he should swim in the opposite direction. Then only with taking this river velocity into consideration, he will be able to reach the opposite point. So if this is 3 km per hour, if this is 3 km per hour, we need to find this angle. So for the time being, I am just putting it as phi. Okay, this angle is phi. Then I am just naming this as theta, and this angle is going to be 90 degrees. So obviously the answer is going to be 90 plus theta, whatever angle we are going to find. Clear? Done. Now to solve this problem, what I am going to do is, for the swimmer to start from here to reach exact opposite point, there should not be any horizontal component or I component. This must be cancelled with the this component of this swimmer velocity. So what we are going to do is we will resolve this velocity into horizontal and vertical direction. So this is going to be 3 sine theta, and this is going to be 3 cos theta, and this is going to be 3 sine theta. So obviously 3 sine theta must be equal to what? 2. Then only horizontal component will get cancelled off. There will be only vertical component, and he will be able to reach the opposite side. So we can do like sine theta is equal to 2 by 3, and so theta is equal to sine inverse 2 by 3. So the answer, if it is there in the option, like we can write like a 90 plus sine inverse 2 by 3. So if this is the option available, we can mark like 90 plus sine inverse 2 by 3. That is the angle he should make with the river flow in order to reach the opposite direction. Clear? Understood? Now suppose if we get options like this, 90 plus cos inverse something, or 90 plus tan inverse something, and suppose if this is not available, then this angle can be represented in many ways. So how to do this? Okay, so here 3 sine theta, and we have considered like sine theta is equal to 2 by 3. Okay, so if we consider this as the opposite of this river flow, we can consider this as 2. So I can put this vector here. This is 3, this is going to be 2. Okay, now how we can find the third side? If we know, okay, if we put theta here, okay, and if this hypotenuse is 3 and opposite side is 2, then we can find this adjacent side. So adjacent side can be found like a root of 3 square minus 2 square. This is going to be root 5. So this could be what? This side could be root 5. So I am getting this side as root 5. So if we need to address in terms of cos, okay, that is also possible. So cos is nothing but here cos theta is equal to adjacent side by hypotenuse. This could be root 5 divided by 3, and in terms of tan, opposite by adjacent, this can be 2 divided by opposite by adjacent, root 5. So all these are correct answers. All these are correct answers based on the angle. So it can ask with respect to this also by giving a figure also. Okay, hope you understood. Clear? Note it down. Now we will have another question. Time taken to cross. Time taken to cross. So now everything is available. It is easy to find the time. So time is equal to S by T. X by Vy. Okay, Sy by Vy. So 500 is the width, and what is Vy? Vy is nothing but this component of velocity. So this could be root 5 hours. Okay, root 5 hours. So 500 meter wide. So if it is 500, if we need to convert this into kilometers based on the option, we can do, no worries. Okay, so let us do like this is 3 kilometer per hour. So 500 divided by root 5 kilometer per hour. So into, if we need 5 by 18, we can do, and we solve this, we will be getting the time to cross the river. Okay, fine, note it down. Next question. So a man can swim at a speed of 3 km per hour in still water. Okay, velocity of swimmer in still water is given as how much? 3 km per hour. He wants to cross a 500-meter wide river, okay, which is flowing at, this is 500 meter, and this is flowing at 2 km per hour. 2 km per hour. So he keeps himself always at an angle of 120 degree with the river flow while swimming. So he is swimming in this direction. This is the river flow direction. So here 120 degree with the river flow while swimming. Find the time he takes to cross the river and at what point on the opposite bank will he arrive. Okay, so pause the screen, okay, and do this question. Okay, done. Over. Right. Okay, so time to cross is SY divided by VY. So here this is actually 3 km per hour. Okay, so SY we know 500 kilometer. If we want, we can write like this, divide by what is the vertical component of velocity. So if this is 120, total is 180. So let us put this as 60 degrees, so it will be easy for us to resolve and solve. Okay, so this is going to be 60 degree. So this is 3 sine 60 and this is going to be 3 cos 60. So sine 60, so this is equal to root 3 by 2. Okay, so that is what. So here this is going to be 3 into root 3 by 2. So into 2 we can write. So this is actually 1000 divided by 3 root 3 hours. This is the time taken. Note it down. Here there is a mistake. This is 1 by, because here this point, sorry. What is the next question? Another question, at what point on the opposite bank will he arrive? At what point on the opposite bank will he arrive? So here 3 cos 60 is what? 3 into 1 by 2. So this is going to be 3 by 2. So this is 3 by 2 means 1.5 and here it is 2 kilometers. So velocity of swimmer with respect to ground is equal to velocity of the swimmer with respect to river plus velocity of the river with respect to ground. So velocity of swimmer with respect to ground is what? Velocity of swimmer with respect to river is minus 1.5 I, and this component we need to take, this is plus 1.5 root 3 J, and this is velocity of river with respect to ground plus 2I. So velocity of swimmer with respect to ground is actually what? This is 0.5 I plus 1.5 root 3 J. This is the velocity actually. This is the velocity. Now definitely there will be a displacement. There is going to be a displacement. So first what we will find? We will find the drift. This is for your understanding I have written. Okay, in order to find the drift, what we can do? This is 1.5, this is 2. Obviously this drift is going to be 0.5 into what? 1 by 3 root 3. 1 by 3 root 3. So here here this is going to be 6. So 1 by 6 root 3 kilometers will be the answer. Okay, that much drift will be there. Clear? And this is the velocity in this direction. Okay, this distance also we can find out. This distance also we can find out. This into time, that distance also, actual distance also we can find out, or otherwise this distance square plus this distance square. Okay, done. Another question. Okay, so this is a river. Okay, the velocity of the swimmer in still water is 5 km/h. This angle is 37 degree. This width is 12 km. This river is moving at an angle, at a velocity 2 km/h. Okay, so find the time to cross the river. Find the time to cross the river first, then we will see the drift, then each value we shall find out. So what about time? Time, we will resolve this into 5 sine 37, and this is 5 cos 37. So 5 sine 37 is 5 into what? 3 by 5. So this is going to be 3. So what is time? Time is going to be distance is 12 km and divide by this is going to be 3 km/h. We will be getting 4 hours. 4 hours is the time taken to cross the river. Right, now at what point he arrives on the opposite side? At what point he arrives on the opposite side? So this is going to be 5 into cos 37 is what? 5 into 4 by 5. This is 5 km/h. So see children, this is the river flow is 2 km/h. The velocity of the river flow is 2 km/h, and the swimmer's velocity is what? 4 km/h. So what is the net horizontal velocity? Is what? 2 km/h. So velocity of the total system, the relative velocity between the swimmer and river, what will happen? Velocity of the swimmer with respect to river is what is this actually. So velocity of the swimmer with respect to ground, if we consider, this is going to be we can consider the vertical component and horizontal component also, but instead of going for all that, what we can do is, this is 4 km/h in this direction, that is 2 km/h in this direction. So what we need to do, just to find the drift, obviously drift will be towards this side. So this drift is going to be, this is 2 km. After subtracting from this 2 into how much hours it is taking? 4 hours it is taking. So 8 kilometers drift will be there towards this direction. So this is going to be 8 kilometers drift. Okay, that is the answer for drift. Clear or what? So 12 kilometer in this direction, 8 kilometer in this direction. So there is going to be actual distance. Actual distance will be like this. Suppose if this is A, this is B, this is C. Suppose if we need to find the actual distance AC, what we can do? Take the vector resultant of the two vectors, 8 square plus 12 square, this is 64 plus 144, so 240, 8 square plus 12 square, so root 208 kilometers. Clear? Cut or what? 140, 60, 200, then 208, done. Okay, distance. Okay, children. So from this topic, minimum distance to cross the river is exactly opposite. They will ask minimum time to cross the river. Okay, then time to cross the river, actual distance, drift, all these things can be asked. So this is a category of problems from 2D relative motion. Okay, so hope you understood the things. Okay, revise it, understand the concept. Okay, just I will summarize. Just what you need to do is, if the swimmer is directly moving in the opposite direction, okay, that is with respect to river, he is trying to flow, then if you need to find the time, just this horizontal velocity divide by width of the river bus. Suppose if he is moving at some angle, resolve this into y component and x component. So if velocity of the river and this velocity of the x component are same, definitely he is going to move in the opposite direction. There won't be any drift at all. Suppose if velocity of the river is more than velocity of this component of the swimmer, definitely he will be moving in this direction. Take the difference of these two, velocity of the river and the horizontal component of the swimmer, that into time will give us the drift. Suppose velocity of the swimmer in the horizontal direction is more than the river flow, then take the difference, that into time will give you the drift in the left direction. Okay, likewise you will be able to solve. And then take the resultant to find the resultant velocity, take the resultant of the x and y in order to find the resultant displacement. Okay students, thank you so much.